Um, Thanks, Sherry, and thanks, Tom, for a wonderful talk, getting us situated and just kind of setting up for what I'm going to be talking about. We did collude just a little bit. So Tom focused on a couple of settings involving computers and students, along with the teacher. And I'm going to talk about two additional settings of students working together in small groups and entire classes of students working together, orchestrated by the teacher. The Q&A raised a lot of really profound questions on the role of AI with learning and what are the socio-technical implications. What I'm going to talk about today is really thinking through this and looking at taking AI from a human-centered AI perspective and HGI perspective of looking at computers and teams of humans actually forming partnerships, and how might they do that in a way that's mutually beneficial to both. So I'm going to talk to you about our National Science Foundation's AI Research Institute. The NSF, for those who may not know, about 3 years ago, decided to fund these large 5-year AI centers. We were one of the first 5 inaugural institutes, or 7, and now they've actually got another 11, and I think they're doing their last round. So you'll really have about 25 of these institutes, and they're focused on these long-term, high-reward AI research to address both technical as well as social challenges. 5 of these institutes have focused on AI in education. That's almost 20%. And this should tell you how important this field is and how important people are considering AI and learning. So our institute is very broad and diverse, and we've got an exciting group of folks here. It's my honor to kind of share their research with you. So this talk will basically have a very simple outline. I'll just tell you a little bit about the institute, and then we'll dive into some of the research that we're doing. And so the kind of central question we're asking is how AI can help promote deep conceptual learning through these rich socio-collaborative learning experiences for all students. So we believe in theoretical frameworks that look at learning as inherently a social enterprise. This is what we're doing right now. We're interacting socially. We're building meaning and co-constructing knowledge together. But as was alluded to by Tom, one of the biggest challenges here is that it's very hard for a teacher to do this in a classroom because there's one teacher and you can imagine 30 students or many, many student groups. So what is the role of AI in helping facilitate that type of interaction? And that's the central question we're addressing. So in thinking about what is the future of AI in education, what might it be, we thought about maybe 3 opportunities here for innovation. So one, how can AI help enhance the bandwidth of communication? So we've had a lot of work over the last 50 years. You know, AI in education is an old field since the 70s on one-on-one interaction. There's still work progressing. And now with massive data, there's a lot that can be done there. But we looked at our institute at enhancing this bandwidth of communication towards multimodal, multi-party, naturalistic social interaction. So what excites me is going into the classroom and what can we learn from a noisy, messy classroom of students and youth having exciting conversations with each other. So that's like a key area of our institute where we are aiming to make some fundamental innovations. The second, there's just not enough time for these kind of older models where you take a math class for 10 years and you take a literacy class and you take this and you take that. Given the challenges in our world today, we actually are thinking about education in a different way, which is what I like to call developing the whole student. So as you're learning your core content skills, besides that, you're also learning important 21st century skills, critical thinking, computational thinking, collaboration, and you're also learning character skills, intrapersonal skills. How do I deal with frustration, feedback, failure? How do I have hope, awe, and gratitude? This should all be part of a well-rounded educational experience, is what we really believe in. And lastly, I think the days are gone where we can develop technology and not consider its social implications and just say, we develop technology with a benevolent outlook, And if somebody misuses it, it's not our fault as technological developers. I think we've seen time and time and time again, the people who are most harmed by these misuses of technology are always the historically marginalized youth every single time. And so we're thinking about developing technology now with a whole different lens, which I want to call AI justice. It's going beyond even ethics and fairness towards the call for justice. And what does that mean? That means those who are mostly marginalized youth, who are mostly negatively affected by technology, should benefit from it the most. So they should be in the room designing throughout from day one. So our institute is aiming to put these three ideas together. I want to share with you some work along those lines. So the broader vision of what we're thinking about is what we call these AI partners. And the idea is computer agents, or computer things, and we don't really know what that role is. Are they assistants? Are they peer students? That is an open research question, but they immerse themselves in small group learning. And in this diagram over here, you can see different types of AI partners. In one case, it's a disembodied voice. In the other case, it's a virtual agent, and so on. But what they're doing is they're listening in on these conversations with the students, trying to distill nuggets of information, help the conversation stay on track, but every time in close coordination with the teachers. So it's the teacher is really playing a very central role here. So it's really the AI and the teachers. And so, for example, what this solves one problem, which is the teachers cannot be omnipresent, so they may not be aware of what's going on in these different small group conversations. But at the same time, students actually sometimes and often have fascinating conversations that the teachers aren't aware of. So can we distill this information? Can we find important nuggets? And can we help coordinate that with the teacher? And very quickly, in terms of some of the outcomes we're looking at traditional STEM and AI content knowledge. The focal domain we're working on is AI education. So we're actually helping students develop AI literacy. So that's what our curriculum focuses on, while at the same time helping them become better collaborators and critical thinkers through the design of inquiry learning environments, where students do experiments and learn about phenomena in the world. And at the same time, we're hoping to develop and help them understand be interested in STEM, curious, and improve their self-efficacy. And an important core component of all of this is for students to understand the nature, behavior, power, and consequences of AI systems. So, and back to what I had mentioned about how to design technologies with an ethical and justice approach, we're actually leveraging a framework. It's called a framework of responsible innovation. And this framework helps you think through in proper steps, how do you be responsive to the needs of your users? How do you anticipate potential misuses of your technology? How do you hold the mirror back to yourself and ask myself, how are our technologies working? What are we doing? And how do you develop an inclusive designs? So by adopting a theoretical framework in everything we do, we're hoping that the technologies we develop will be more closer to what youth and students and teachers want or tell us what they want and need. So very quickly, we've organized our institute into these three core research areas. So one focuses on foundational AI work. This is basically understanding and facilitating collaborations in the classroom. The other one focuses on learning scientists, looking at how to broaden participation in technology and design and co-design. And the middle are folks who are experts in team science, computer-supported collaborative learning to help orchestrate these technologies. And what you actually see is also a community hub to integrate these different researchers. It is very difficult to get 100 people who represent 15 areas to come and sit together and have a shared value system, right? So one of the things we're hoping to do in this institute is actually hold the mirror to ourselves and try to understand, what are we doing right? What are we doing wrong? How are we actually studying ourselves as an example of these large collaborations? So what I want to do is just give you a quick selective overview of our work today, and leave plenty of time for questions and discussions, hopefully. So there's a lot of theories guiding our work in these three research strands. There's just a list there. We don't need to get into that, but I just want to point out that the intellectual diversity in these large initiatives becomes very, very exciting. So our kind of research process goes something like this at a very high level. First, we have what we call Learning Futures workshops, where we engage youth, primarily youth of color, to have expansive views about how they see technology and AI supporting collaboration in their classrooms. And this is when we have these conversations about what data they're comfortable sharing, what data they don't, what do they want that makes them feel secure with having microphones and cameras in the classroom and things like that. This leads to a lot of design on how to actually design intentionally different technologies. And then we go in and develop them in classrooms, collect data in classrooms, as well as study the impacts. And throughout the process, we're hoping to be doing a lot of dissemination of knowledge and transfer. So what I'm going to do now is just go through some of these three main blocks. So is how could technology support collaboration in the classrooms? And what are you comfortable with? And a couple of things come to mind. So when you're talking to folks who all they have experienced is the institution of schooling and the way education works, it's a very, very entrenched structure dating back hundreds of years with very, very resistant to change. You have these institutionalized pressures. It is those pressures of the institution really pull you down when you want people to have expansive visions about learning. So also thinking about innovative methodologies to do design that break free from these institutional pressures. And one way we do this is through these Learning Futures workshops, where you take people outside of the context of the institution. So in this case, what you see on the right is we took people, kids in the East Bay, California, to a 70-person cooperative house. So they see how collaboration unfolds in the real world outside of the grammar of schooling. So they could think about, oh, wow, how do 70 people live together during COVID? How do they get along? And this led to an important shift in how people think about these technologies and what they could accept. I'm going to come back to that later, but I'll just tell you a few insights we've learned from doing these Learning Futures workshops. One is what the youth actually wanted. They wanted the AI to help them build better relations with each other. They were less interested in actually the AI helping them learn content and knowledge. They wanted their contributions to be heard, attributed, and to have meaning. And obviously, they did not want the AI partners to report any poor behavior to the teachers. They didn't want a snitch and a police in the classroom. But at the same time, they were very sophisticated. They were totally willing to give up certain data about themselves in exchange for features they value. But they wanted to be on their own terms. They wanted to be able to turn off the microphones when they're having certain conversations. What a thought. Can the youth turn off the AI, right? We took these ideas and we organized what we call a design sprint, where we actually brought our folks from the Institute to sit down and really think through, based on what we're learning from the students, and we've also done interviews with teachers, how could AI support video just to show you some of the people really behind our Institute. And this is a test of the sound system. Oh.
So one important aspect of ISAT is to consider the role that AI should play in classrooms. And a way that ISAT has done this is to institute a design sprint.
I was one of the facilitators for the design sprint. The aim of the design sprint was to develop a more refined set of metaphors or ideas about how AI can be used in classrooms, keeping in mind how it will impact teachers and how it will impact students. So this allowed for a really interdisciplinary group of people to come together and quickly, within 3 days, come up with some designs.
The design sprint was a resounding success in getting folks from all of these different universities and backgrounds to come together and have a space, safe and creative space to design together. And they had 3 really impressive designs that actually target the entire life cycle of ISAT, ranging from interacting with students to teachers to organizing classrooms.
Gradually now, we built up that to basically execute this to a code where we'll see how we come up with this single partner and see how it functions.
Artificial intelligence done right can be such a powerful tool, right? Because it's really difficult for a teacher to reach all kids every time, every class, and every day. And I think with a potential AI can do is they can see where the students are and kind of help them to guide them.
And this led to kind of 3 different designs that we thought about. And supporting collaborations, it kind of falls on 2 dimensions. Do you support the task and the content, or do you support relationships? And you can do both. So one of the designs we're thinking about, this is a more traditional design. It's what we call a co-pilot, kind of modeled after the GitHub Copilot. But basically, it's giving small group support and collaboration by providing guidance on a task. But remember, we want to go beyond the individual and the individual group to the entire classroom. And so the second design is that what we call an augmenter. This is really focusing on the teacher, where you distill information from these different groups and help the teacher orchestrate the interaction. And on the other side, in orange, what you see there is this idea that came from those Learning Futures workshops entirely from the youth, and they wanted support for community building. And this is how does AI and technology help students develop trusting collaborations with themselves, with the AI, and with the teachers. And so we've been working on different designs that address these different aspects. And what was interesting was this was very different from how we thought about AI partners when we originally proposed this to the National Science Foundation. We thought about this top-down guide who would help the groups and a sheepdog that would shepherd them. And the kids, you know, they were fine with some of that, but what they really wanted was their own agency and their own voice in what the technology would do. So let me just tell you a little bit about now some of the work we do in the classrooms to just ground this in actual curricular experience. So one of the curriculum units we're working on is called Sensor Immersion. And this is an awesome unit, I just have to say. I participated in it myself. Basically, kids learn how sensors can sense the world around them to measure meaningful things. And then they actually program these sensors, both using code as well as physically wiring them. There's a sound sensor, there's a moisture sensor, there's a environmental sensor. And the idea is that they first get exposed to sensing, they learn some computational thinking, and then they come together to solve projects in their community. And what I wanted to show you is, let me just show you a little video of what these interactions might look like.
It has pictures of the different electric circuit. This one's easily explanatory. Oh.
Not.
Not?
No. Wait.
Other than black drawing of an ecosystem. I mean, it says everything in there.
Observing a bird feeder.
Okay. Yeah, this one looks pretty decent. You probably explain that.
I don't think this is explanatory. Yeah. So you're just observing a bird.
Yeah, observing isn't really explaining.
Yeah. Drawing.
Okay, logic. If true, if else, okay. There. We're gonna move this forever over here. We're gonna move this forever right here. And it's showing us this weird random image that we don't need.
I think before we download it, we need to change the C thingy to.
It says high C. Looking it up. Here, I got it. Good job. Red right here. Where does the green one go? P20. That's where the green one goes? Yep. Then yellow goes red one.
So I hope you notice some of the technical challenges here of actually being able to make sense of these conversations in the classroom without like wiring up the whole classroom. So first of all, there's a lot of really noisy speech. Then speech is grounded in references in the reference in the real world, as well as eye gaze as who's looking at what. You have a lot of the conversations are not actually spoken. There's a lot of pointing and gesturing and nudging and hinting. So it's how do you make comprehensive sense of what's occurring? And that's like a really, really difficult technical challenge. We're using these big microphones. They're called Yeti Blues. They're actually pretty good, but they are inexpensive, maybe $130 relatively. But they have this presence in there, so it's really clear that you're being recorded. I want to show you a little bit about different types of data, so you can get a sense of what that might look like.
So there's two students who sit on that side with this iPad viewing them, and then there's another pair of students who sit on that side with this iPad viewing them, and the Yeti mic between them. There's a wide angle camera that's set up in the back there, and then I am using the teacher following camera, which is usually set up back there.
Yeah.
No.
It goes on GND if you
No,
read
but
the...
you don't go like that. You don't go like that. Yeah. No.
Can you let me do this? You're stressing me.
I know. I'm very stressful.
Wait. It has to go like that. Okay.
No, next. Now red goes here.
Red goes where? On the other side?
Yes.
Okay, so you have power. Wait, I don't think we have power, but we're putting it back. I think we did.
I'll show you the same thing with the video now.
On GND. Yeah.
No.
It goes on GND if you
no,
read
but
the...
you don't go like that. You don't go like that. Yeah. No.
Can you let me do this? You're stressing me.
I know. I'm very stressful.
Wait. It has to go like that. Okay.
So you can see the importance of the multimodal information in these contexts. With these data, we've collected a ton of data, and I'm really impressed by our team. We had to do all of this during COVID and Delta, going into the classrooms. These kids are unvaccinated. They barely wear masks. It was pretty scary, but we really needed this data. So we've got a ton of data. We're also working on these sharing data repositories. So we're hoping this data will eventually be shared more widely to the community. But for now, we've been looking at this data from many angles. I'll just briefly mention one. One is very much focused on speech. So what are they saying? Low-level speech. Who's speaking? Who's saying what? Who are they pointing to? And all of that. And how is speech grounded in the world? Then we look at a lot of talk. So looking at different frameworks of talk. So one is about basically, are they having conversations that are with respect to the task or the lesson? But also, are they having rich quality discourse? What is the value of the student discourse? There are frameworks of talk that you can leverage. And here's one that is academic productive talk. So what we see in this is that kids, they make a lot of claims. This sensor does this sensor does that, but what they don't do is provide reasoning for those claims. So this is an example where an AI partner can kind of help them elucidate some of that information. We do a lot of work on collaborative problem solving, looking at how different models of collaborative problem solving can be applied here to understand collaboration more broadly. And then there's a whole different set of work focusing on how do the peers support each other and how do the teachers support the student groups? And the hope is to distill some of that information into developing an AI partner that can actually emulate some of those behaviors. And just to give you one example, here's the collaborative problem solving kind of framework we had developed in some previous work. And what you see here are how we actually go about coding these audios. So what you see here, this framework has 3 facets of collaboration: sharing knowledge, negotiation, and keeping the team kind of together. And within each facet, there are these different verbal indicators. And you can see here in a different data set with 2 different domains. So one is in physics and the other one is in like computer program with Minecraft. And the idea is, how do we develop kind of generalized models of collaborative problem solving that can work across these different domains? So let me just tell you a little bit now about our technology and what we're developing. So what is our theory of change? How do we envision getting those learning outcomes that I mentioned? So one is this direct path through well-designed curriculum. So we work with some of the world leading experts in how they make engaging curriculum design. And this is really thinking about curriculum that is that students are interested in. They have inquiry, there's collaboration in there, and it's difficult. None of this is actually easy. But the idea is, can you leverage the power of students working together to kind of deal with some of those challenges? But then we feel that in addition to curriculum, there's a magic of socio-collaborative learning experiences. Going back to the day where people learned by sitting under a tree with 10 students at a time. So, but how can we create these rich socio-collaborative learning experiences that bring out the best? But then can the AI partner designs moderate those experiences to enhance them? So this is kind of how we're trying to put the pieces together. And each of these are testable links that we can use to test out different ideas. So we then think about the role of AI in different ways. So we're thinking about these AI partners as both interacting with individual student groups, engaging with the teacher, but also at the whole classroom level, at a community level. So there are some really interesting dynamics to be modeled here. So I want to talk to you about one partner we're developing called the Community Builder, a Kobe. So when I showed you the video on the right, of the image of the right of those kids touring the Berkeley Cooperative House to see how collaboration unfolds in the real world, one thing that really struck them is they could not initially understand how does this even work without a police state? And I want to point out that these are all youth of color who are living in a society where there's extreme policing all the time and surveillance. And they were exposed to this idea of community agreements. So these are agreements that the 70 House members create among each other and then hold each other accountable to monitoring these agreements. And this led to a shift in thinking about technology from policing them to supporting them live together. And this is one of the designs created by the youth called the Live, Love, Light device. And it's a design on how to monitor conflict. And the idea is you have an agreement with your team on what are the things we should avoid, like curse words, slurs, loud volume, and so on. And then when you're having a disagreement, the technology is listening through for those indicators, and those devices light up to get your attention back as to what's occurring. And it's just a very passive way to think about using AI to kind of help these youth with these relationships. So we were inspired by that design to actually take that core idea and develop an AI partner called the Community Builder that focuses on different 4 agreements, such as respect, equity, keeping our thinking forward, and advancing a learning community. And the AI technology will listen in on these conversations at certain moments and then think about how to display the information. Here's one visualization where the information is displayed quantitatively. Here's another one where it's described qualitatively. So as these noticings, so this design is a little clunky, we've cleared it up, but basically you can think about these 4 agreements, and what the AI does is it tries to sift through examples and hold them out to the students, but then the youth can have conversations as to when they disagree with the AI, when they agree with the AI. And the point here is not to have the most accurate AI, because we'll never have that, and find the best examples. It's to have a conversation. This is what you said you think is respect. This is what the AI said. Let's have a conversation and learn something about it. And that's really the main goal here. And underneath all of this is a lot of theory, and we're working on what we call conjecture mapping. And this is a way to think through, what can I do in the back end? What can I do in the front end? What are the mediating processes, and what are the outcomes through these different links? So if I want to show you those 2 designs, the quantitative design has the disadvantage that kids can just game it, right? You give people numbers, they can increase the numbers. Will that lead to meaningful change? So we can test these different theories, and what you see in red are some unintended consequences of the technologies. What can go wrong? So this is part of that responsible innovation framework, where you need to start anticipating what can happen and what won't. So when we go and design experiments, which we're doing now in the spring and next fall, we can take pieces and pathways off this conjecture map to test those empirically. So let me just say a little bit about the technical challenges here. And so there's a lot of technical challenges, right? Because what we're trying to do is build an end-to-end system. We're kind of analyzing classroom audio and video. And there's many steps. So there's acoustic processing, there's speech recognizing, there's speech diarization, there's content analysis, there's conversation analysis, there's collaborative analysis. So what is being said? Well, first of all, is something even being said? Who is saying it? What is being said? Who are they saying it to? What is the intent between what they're saying? And that's communicated in how they're kind of saying it. And it's multi-party, multimodal, multi-curricular, and real-time interaction. So there's like a lot of risk everywhere. So failures can accumulate and so on. And we've developed a little bit of an inference engine to support this. And basically what happens is essentially we focus on speech and diarization first, and then it runs through a set of models to predict different things. One important point I want to say here is that we've started with these initial like basic components like Whisper AI and Google Speech, but we've collected enough data that we can now fine-tune these speech recognizers to our own acoustic environments. So here's an example. So speech is a big challenge, right? So here's an example of some classroom audio, and this is through this is about a year ago. So 3 different speech recognizers. And what you see here that's kind of very interesting is the 3 different types of speech recognition errors where you see substitutions, words are substituted, insertions, words are inserted, and deletions where words are just removed. And what we notice is there's a lot of trade-offs. So Google tends to be very, very conservative. So it like does not give you any speech for like half the time. But the other ones do give you more speech, but they're more inaccurate. And then the question becomes, how do you put these things together? Imagine trying to do real-time interaction where you can only get every other turn, right? So we've done a ton of analyses here, and there's kind of an interesting finding here. One, most of the variance actually lies with the individual utterances. It's not some systematic thing or systemic thing about it's bad for these speakers, it's bad for these classrooms. It really is this immediate, what's happening now in the context that really determines where the errors lie. And secondly, this is good news. The ASR errors have a much larger impact for these very low-level parsing kinds of things. Like if I'm doing a parse tree, abstract meaning representation, they have much less of an impact down the stream models, which are more robust to these errors, where you don't need exact representations. So that was at least some positive news. And so one of the things we've done is try to take these models, and this is building for more work. This is a model of collaborative problem solving that looks at different ways of representing the language, either through a large language model or through old school n-grams, or even through dictionary-based approaches. And here we were interested in generalizability and how to give feedback. But the main point I just want to make here is that you can do quite a bit despite noisy speech if you're focusing more at the discourse and collaboration levels and less at kind of the more literal levels. Just very briefly, some other things we're working on kind of foundationally. My colleague, Jake Whitehill, is working on this idea of compositional embeddings to do speaker diarization. Because what happens many times is there's a lot of overlapping speech. So how do you create embeddings that represent, like me and Sherry are an embedding of joint speakers talking together? We use these speaker diarization, what we call TAD, Target Activity Detector, to filter out a lot of background speech in the classroom. He's also working on being able to do some automatic analysis of eye gaze, just gaze direction, very rough, looking at different, to see who's talking to whom and where are they looking. And lastly, our colleagues at Brandeis and Colorado State are working on JAMR. So AMR is an abstract meaning representation of language, used to represent language in such a way. And here they're working on representations that incorporate gesture in these abstract meaning representations. So what I want to do is just show you a quick demo of like some of the processing pipelines. And this is a researcher view, what we would see as researchers. And we've been working very hard to actually improve this. This is an older version, but I just want to show you what we can sense in the classroom and how noisy it may be and where the potential is to do some cool stuff.
At the NSF AI Institute for Student AI Teaming, we have developed a speech-based AI display for small group collaboration in classrooms. We are an interdisciplinary community dedicated to transforming classrooms into more effective, engaging, and equitable learning environments through developing and refining AI technologies. Here we highlight what we can currently sense in the classroom in the form of a researcher display. We currently display data on student groups at multiple levels, including acoustics, conversation, content, and collaboration. The specific metrics include the signal-to-noise ratio, the number of words spoken, and the words themselves via automatic speech recognition, degree of topic and task-related talk, and collaborative problem-solving metrics, including building knowledge, negotiating, coordinating, and team function. We can also explore the raw JSON output that is generated by the AI pipeline, which includes each utterance and diarization of who said it. We will now show the display running with 7 groups in the classroom.
And then you have try to get it like this, or you could.
Like, why is nothing like? Did we do something that right? Maybe I think the thing we probably did was we didn't plug something in the right place on the code.
It's hard to tell. Sorry about that. It's very loud outside. It's typical classroom environment. But the main point here is that
student privacy and agency critically in our designs. For example, students can turn off the sensors when they want some privacy. Overall,
the main point is that you can sense a few things, even with basic off-the-shelf models. And then with some of these open source models like Whisper AI for speech recognition, you can fine-tune them using data in classroom environments. And the latest news on speech is that because these are end-to-end models, you don't even need separate language models. You can just do a lot from the acoustics. And we've been able to sense a few things, pretty marginally accurate, but now we're trying to put those together in our first AI partner, which we'll be testing. I want to end by just talking a little bit, taking a step away from technology and education and just talking a little bit about teams. I also do research in team science, very interesting to me. So I want to just talk about some experiences in how to build these multidisciplinary, multi-organizational teams, and what are some of the things that might be useful and what has worked and what hasn't. So, we're across the country, and we started during COVID, really, in 2020, September, like the worst possible time. There are some challenges of how to get people integrated. And as I said, we're kind of representing about 15 different areas, all the way from foundational AI to team science and AI ed to learning sciences. These disciplines have a kind of, it's very interesting how the learning scientists don't really talk to the AI ed people and everything like that. And how to kind of foster these interactions has been quite interesting. And then thinking about developing this partner, actually, there's so many inputs. Here are some. There's the curriculum units, there's the learning outcomes, there's the student inputs through these learning future workshops, there's these teacher perspectives, we have a teacher advisory board, there's what can you do computationally. So the foundational AI people are very, very concerned about that. There's what does theory tell us and what does research tell us. So these are all kinds of inputs. And what we felt is that intensive design sessions is a really, really great way to not be overwhelmed by the different space together. So we do these design sessions that serve as convergence points. And when we do some strategic planning sessions where we get everybody together, and then you also want divergence points. So we also have a lab set up where we can test all kinds of things in the lab that you can't really do in the classroom. And that leads to certainly interesting different ways of convergence and think about designs. And then the third point is high fidelity prototyping. So when you're in the classrooms with technology, it kind of forces you as a constraint. So it's really interesting to kind of think about how these different pieces can come together when you have a lot of different folks. And then, I just want to emphasize again, talk is cheap, artifacts are where it comes. So being able to think through the processes and different artifacts at every level has, I feel, helped us function more cohesively as an institute. But of course, there's always a lot more you can do. So, it's important to reflect on how important it is to be in person after working remotely for so long. And we felt, at least, that's been important for our team, given we're also working in actual classrooms. So you can see some of the sessions we've had there on the right, and then the left is some of the actual classroom work. So thank you very much for your attention, and you can learn more at our website, and I look forward to your questions.
Yeah,
so please go ahead.
Yeah, I'm Richard Tong. So I'm one of the co-organizers of this seminar. And I do have two questions. And also, Sherry, I think there are some questions from the live audience on the on the chat. So my question actually is about efficacy and feedback, right? So when you say these, you develop these community builders, you develop the co-pilot, you develop the augmenter, all these key functionalities from the asset project, right? So what are the measurement of success, right? How do from a machine learning point of view, what are the signals are we looking for as a feedback signal so that we can improve the algorithm or improve the design or increase the efficacy, right? So in general, there is a general efficacy, what does this really help, right? What are the areas that are you looking for help and how do you measure those results? So that's kind of like a broader question, but more specifically on those key functionality, you're talking about, using these co-pilots, say, right? So in the co-pilot case, what are the specific functions in the co-pilot and how do you use local signals or broader, longer term, longitudinal studies and so forth to inform like which works and which doesn't work? How do you build that into both at the model level and also as a design level, right? So that's my question.
Yes, thank you very much. So a couple of things. So first of all, some of the measures are very traditional, right? Speech recognition, you look at this, and so on. I think what's really interesting, and Richard's question gets to this, is when you're building an algorithm that is then used as input to another algorithm that is then used in a technology that's in a classroom that's actually interacting with people over time, suddenly the questions of efficacy and effectiveness become very interesting. So you can start with a speech recognition error and you can say, I reduced my speech recognition error by 10% by fine-tuning on this. Then you ask, what impact did that have on the collaborative problem-solving classifier? And you can say, well, it's Y. And then you can take that and put that in the classroom with two different, maybe types of algorithms and say, in this small study with version 1, version 2, what was the difference? And then so on. But as you're going from this, from the algorithm through, did it improve collaboration in an 8-month period? The question of how you identify efficacy and give credit is actually a really interesting problem. And we're only starting to think about those designs. We know how to do efficacy studies in a very traditional way, but I think this is another area where we need to do some innovation in the field because we're thinking much more going back to the medical models where they've been learning this the whole time, right? Personalized medicine, when you're doing a clinical trial. So it's a lovely question. And we are starting now to get together a team of people to think about how to do efficacy and effectiveness in more intentional ways and more, frankly, cost-effective ways than doing this large RCT kind of thing. So it's a great question. And I think there's some innovation in methodological innovation to be had around it.
Sure. Thanks for the great talk. So I have a question basically about the multimodal part, like how you collect the data, specifically because I do CS education more. So I wonder how can you just think about a way to involve the artifacts that students created in their process? For example, if they just wire the lines, as we see the video, right? The order of the wiring might be indicative about students' learning outcome, or something like when students do the programming, then can we just use the programming data to do something? Just want to see
it's a great question. So in an ideal world, what we would love to do, and we're doing some of this, is being able to perceive all those discrete elements. They wired this, they did that, they did this block, and you can get some of that, some of the online stuff from log files and everything. That's fine. I think where we've been focusing on a bit differently is there's been a lot of amazing work. For example, Tiffany Barnes was here on hint generation in programming environments and all kinds of things. We've been focusing less on trying to emulate some of that work and just leveraging what is out there. And we've been focusing much more on the discourse. And we've been trying to figure this out by figuring out what can we learn from the conversation and the speech with a very, very minimal understanding of the context. And that's how we've been operating right now, because there's just so many problems to solve and we can't do all of them. But we have little things. So for example, when they program the code, there's an auto grader that can at least tell if the code is correct, and that can help them kind of do the conversation, right? So our focus is really much more being on the discourse, and starting out mainly with speech, but we're starting to roll in some of these more multimodal models down the road.
Sure, thank you. I guess there are also some like collaboration opportunities because, you know, I also work with Tiffany and Thomas Price, so.
Thank you.
So we have some questions online. So after these two questions, we're gonna, if we have time, switch to online also.
Thank you for the amazing presentation. My question is, when we using AI for for children, how can we avoid distraction, and like how can we balance the students' curiosity about the new technology and make them actually focus on the learning objective? Because I also do co-design workshops with children, and I built AI agents for them, and I record all the conversational data, but I find that students are curious about the name of the name of the mother of the agents or something like that. So like how to avoid such distraction. Thank you.
Yeah, another terrific question. So one of the things that we've been thinking about a little bit is, what is a right interaction? What is a form of collaboration? And this is going right back to what I was saying about the institutional pressures, right? We in the educational system have applied the principles of Taylorism, you know, to industrial stuff to have efficiency, efficiency, efficiency. And we're pushing back at that a little bit. That is important, certainly, but a good example is off-topic conversations, right? When the kids go off topic, well, 15% of the time. But guess what? Some part of that is about rapport building collaborations with that. How do you use that information? Others, if they're being 90% off topic. So we've been trying to think kind of differently on what youth communication. And don't get me wrong, there's disruption, right? These are kids and they can be mean to each other and all of those things. With respect to what I want to use is non-normative discourse. What are the things that they're saying that we say, this is normal, this is how you should behave in the classroom? Let's push back at that a little bit. Let them be children. With respect to the technology, my fear is how to introduce it in a way that they trust it and can rely on it to the right level. How to do that in a scaffolded way, so it's not just a novelty effect that after day 2 it's done. And we haven't figured that out. And with thinking about how to do that. Yeah, thank you.
Thank you.
My question is really about what would be a best practice for teachers if they were in this situation of trying to help with collaboration. So for example, you showed us this class where kids are learning to put together sensor systems. And I think the long-term target is to have an AI system there that might help with the collaboration. Have you studied, like, I'm sure you have some teachers who've taught that class a bit. Do you have a characterization of what are the best strategies, what do those best teachers do? And how well shaped is your understanding of what works, what good teachers do?
Yeah, thank you for that question. We're in the process of doing that. So we are looking at when the teachers go to each student group, why they went, were they summoned, or they were just doing their rounds. And then we look what happened a minute before, during the minute, and a minute after, to try to see how did given that context, with, you know, trying to formulate this as a very simple reinforcement learning problem. We're just looking at that right now. I'll tell you what they don't do. And what they don't do and what they don't want is when the kids are working together and doing their things, what they don't want to be doing is staring at a dashboard of AI saying, do this, do this, do this. And this is a really important thing, going right back to what you're saying about you know, medicine and the doctors and how they embrace technology. They just feel like that's not their role. And what they What they are more interested in from conversations with them is how to orchestrate these whole class summaries. So when group work is done, how can the information lead me to have these bigger conversations? So we're very much looking to see like what the teachers are doing, how they're helping. But what we see a lot of is checking in and encouragement and diagnosing small problems and focusing a lot on how the youth are actually communicating with each other. So that's what we've been seeing, what some of the teachers are doing. Yeah.
Thanks.
Thank you so much, Sidney. So there are some questions online. I start with the more specific ones. So Lawrence is asking, do you foresee cameras and mics in student groups in classrooms across the US in order to use this innovation, or a new decided piece of hardware or a phone?
Yeah, we've been so we've been trying to see like what is the trade-off, right? We cannot we cannot like instrument wire the whole classroom. But at the same time, what can you do with a phone kind of microphone versus a better microphone? And the reality is that for certain more generalized, non-real-time things, the microphones I showed you tend to be fine. What would happen with a phone microphone? We're doing those experiments. But for actually doing real-time interaction, like a dialogue agent in the classroom, I'm starting to think you're going to have to individually mic students. There's just so much of noise, and given how important decent acoustics is to these speech engines. To give you some context, Google and all the speech recognizers, the word error rates on standard corpora are now under like 10%. In the classroom, it's 80%. That's the word error rate, right? So it's just astronomical. And so when people tell me speech recognition is a solved problem, it's amazing. And then the whole, so I can envision different microphone setups that could work with different capabilities at this point.
Thank you. And Feng is asking he's asking how you evaluate grouping the students. What's the metric to know if a group is a right group or not, if you do that?
Yeah, terrific question. So in one of these lessons, to give you like a concrete example, we call it jigsaw. So one group becomes an expert in one sense. It's a very common collaborative learning experience practice. Another becomes an expert in the other one, and then they solve problems individually. Then they come together to pool expertise like a jigsaw puzzle, right? That's opportunities when we're thinking, and this is again another area where teachers would like some support, is how to recommend formations that says Sherry would work with this person best. So we started to just look into that problem a little bit. But again, most of it's based on what happened in that individual group conversation, how much they were talking, and so on. This is a really terrific opportunity, I think, for AI, because I don't have to only see me in one group or in one session. I have my history over time. And that's one thing teachers are very sensitive about, by the way. They know which kids put together would behave in certain ways, what are the social dynamics, so they're very, very attuned to that. And this is, again, an area where I don't think the AI needs to try to figure that out. This is where the AI can work with teachers and kind of pool their knowledge together and so on.
Thank you. And Shelley is asking, like, in the human AI collaboration, who has the final say?
Who has what?
Who has the final say?
Always the human. So we are very clearly operating from this perspective. And when I was taking my first AI class, our dream was autonomy. That was the dream. Autonomous agents, right? That really was the dream. And there's some value to that dream. But I think right now I look at the view of agents doing things that they can do best, which is basically finding patterns in large volumes of data, coordinating with humans with what they do best, nurturing and supporting one another.
Thank you so much. I think because of time,
Thank
there
you.
are lots of more important questions, but thank you. break, but because of so many interesting conversations, we are going to skip that and continue to the awards. So sorry about that. If you need to take a break, please feel free